Hello everyone. Today we are going to see the topic finite automata, which is one of the core part of theory of computation. This topic will help us to understand how compiler and many other automated systems work. Today's objective. By the end of this session, we will understand what is finite automata, why we need, where it is used in real-time applications, the three important types of finite automata: deterministic finite automata DFA, non-deterministic finite automata NFA, epsilon NFA. This gives us the foundation for studying upcoming topics like grammars and Turing machines. Let's look at the vending machine diagram. Vending machine work like finite automata because it moves through fixed states based on input from user. The machine starts in idle state. When the coin is entered, it moves to display state. When the customer selects product, it goes to waiting for selection state. Then product is selected. Then finally the item is dispensed. If the process is cancelled in between, it moves to refund state. After finishing this process, it always returns to ideal state. Here, key point is vending machine shows how finite automata work in real-time applications. It has simple rules, limited states, clear transition based on user input. The finite automata help us model machines like vending systems where actions move the system from one state to another. So what is finite automata? Finite automata is like mathematical machine. It reads input string based on rules and finally it decides to accept or reject the given strings. It has finite number of states, transition between these states, starting state and final state. It processes the input step by step, moving between states based on different rules. Why we need finite automata? It is used for simple decision making systems. It is used to check whether the input follows particular rule or pattern. Let's look at some examples. The given keyword in programming language. The given password is correct or not. The given message is following correct format or not. Finite automata is used to check all these things. Applications. We use finite automata in many places. In compilers, it is used to find keywords. In search engines, to find patterns. In digital circuits, it is used to control signals. In network systems, it is used to check message order. In spell checking, in simple robot movement. Here, finite automata is simple, but it is very useful one. Types of finite automata. It has main three types: DFA, NFA and epsilon NFA. In DFA, only one route for each input. In NFA, many possible routes for given input. In epsilon NFA, one can move without any input. They look different, all three, but all do the same kind of jobs. Deterministic finite automata. In DFA, for every state and every input symbol, there is exactly one transition. This means machine always know exactly where to go next. DFA formal definition consists of 5 components: Q, sigma, delta, Q naught, F. Q refers finite set of states, number of states. Sigma represents set of input symbols. Delta represents transition function. DFA exactly one transition. Q naught represents starting state. F represents final state, acceptance state. DFA is easier to implement compared to NFA and epsilon NFA. Non-deterministic finite automata. In NFA, a state may have multiple transitions for same input. The automata can select any valid path. The transition functions return set of possible next states. It is more powerful than DFA. It has same 5 components as DFA. The only difference is delta, because it can move for set of possible next states, but in DFA it can move only for only one state. Epsilon NFA. An epsilon NFA is part of NFA that can move from one state to another without consuming any input symbol. For example, using epsilon moves, we can combine smaller automata into larger ones very easily. In conclusion, DFA has only one fixed next state for each input. NFA can have many possible next states. Epsilon NFA can also move without any input. Let's consider easy example. Imagine a game with rooms. Each input takes you to new room. If you reach the goal room, you will win. If you not reach the goal room, you will not win. This is exactly how automata accept or reject the strings. Here, the relationship between vending machine and finite automata is given. Think of a vending machine. 0, 10, 20, this kind of amount represent states. Coin inserted is input symbol. Machine moves to next amount, that is called transition. Starting with 0 represents starting state. Finally, exact amount reached and item dispensed is acceptance state. Similarly, for traffic light and password checking also, finite automata is used. In conclusion, we can see that finite automata is simple model that uses states and rules to check patterns, and it forms the foundation for DFA, NFA and epsilon NFA. Thank you.